I believe that everybody has a story, and I'm fascinated to hear them. So come with me as we take a walk down Fascination Street. Welcome back, Streetwalkers. This episode is with David Mittelman. David is a PhD and the CEO of Othram. He is also the editor-in-chief of the Forensic Genomics Journal, and he works closely with the Texas Medical Center, specifically MD Anderson. Othram is a DNA company that helps build a profile with tens of thousands and even hundreds of thousands of DNA markers. This technology and this company, Othram, are completely dedicated to solving forensic whodunits. They give names to the unknown, whether that is a victim or a perpetrator, and they help solve cases. They help bring closure to families who didn't know what happened to their person. So, of course, we talk about all of that and how he got started in doing those things. And then we talk about his other project, DNA Solves, which is a database where people can voluntarily upload their DNA specifically for forensic use. It's only used to solve a crime. That's it. But this will help through genealogy and genomics, help identify nameless victims and nameless perpetrators. This is a very engaging episode. It's pretty technical in some spots, so try and pay attention. This was recorded during all the self-distancing due to the coronavirus outbreak. So if that is over by now, woohoo. If not, damn it. But either way, this is my conversation with the CEO of Othram, Dr. David Mittelman. A special shout out to Vincent from the Gone Cold podcast for connecting David and myself so that we could make this thing happen. Thanks, Vincent.
Yeah, talk to me, yeah.
Welcome to Fascination Street podcast, David Mittelman. How are you doing today?
Doing good. Thanks for having me.
It is 100% my pleasure. Now, for the listening audience, in February of 1974, a young woman named Carla Walker was murdered in a small Texas town, and it went unsolved until 2020. That is how I came across our guest today. David Mittelman is a PhD and the CEO of Othram. Is that in Houston or the Woodlands area?
It's in the Woodlands.
So, David, first I want to talk about where you were born and raised, man. Where'd you grow up?
I actually grew up in a couple places. I grew up in Boston when I was very little, and then most of my childhood in Dallas.
What did you want to be when you grew up, man?
You know, I didn't have any preconceived notions of what I wanted to do when I grew up, but I was always fascinated by genetics. And I went to school hearing about all these things people were learning about from DNA and how DNA was going to change the world. So I did take an interest there. I wanted to be part of that, and I wanted to understand how DNA makes us who we are. I didn't know what the career would be, but I definitely took an interest in DNA stuff.
Like early, like in high school?
Yeah. In high school, you know, I began to hear about this thing that, you know, people now know as the Human Genome Project. And I was heartbroken that I was in high school and unable to participate. But luckily, the project took longer than expected. And I was able to jump in at the tail end and get involved. And there's a lot of exciting things that happened in that project, you know, not just learning about DNA, but just kind of getting experience in how to engineer laboratory technology, scale it to measure lots of things at the same time. It was a very, very, very fun time. So that was kind of my entry point, the Human Genome Project, and then kind of went down that rabbit hole of DNA research and never left.
All right. Well, while we're on the topic, what is genomics and deep sequencing? That might be jumping a little ahead, but I just want to clarify what that is real quick.
Yeah, so there's two related terms, right? There's genetics, which is kind of the understanding of DNA, heredity, and how all these different things can interplay to produce, you know, who we are. And then genomics is a kind of a discipline of science that uses technology to kind of understand in mass. You know, our genome is all the DNA in our bodies, and that information in its entirety helps kind of shape who we are. So genomics is kind of an area that looks at how do you assay and measure the genome, all the DNA that you've got, and then kind of just understanding how the structure and function and evolution of all these DNA components work together to produce who we are.
Interesting. All right. That sounds wildly complicated. So let's just assume that you didn't pick that PhD up from the back of a cereal box. Where'd you go to school?
I went to school. I trained at Baylor College of Medicine, so that's in Houston. Before that, I was a staff researcher at UT Southwestern. That was during the first genome project. But I trained at Baylor College of Medicine. Baylor had its own genome center, one of the large 3 centers funded by the government to do these mass genomics projects. And so I actually trained in the biochemistry department at Baylor and didn't really get into the kind of genomics and DNA testing until a little bit later in my postdoctoral training that was also at Baylor.
Is that when you did genome in a bottle?
That's a little later. So I had kind of had this, at this point, I had this kind of plan that I would do research full time and, become a professor at one of these cool schools that do genetics research. Baylor's an amazing place for genetics research. The genetics department at Baylor, when I was there, was a top funded genetics research institute from the NIH, which is a government branch that funds this biomedical research. It's just an amazing place. And so I wanted to become a professor, open up a lab and do research. And then after I did that, I went on to join another university. I joined Virginia Tech, where I went along with other folks that had gone to start this new kind of genomics institute at Virginia Tech. And it was there that I started thinking about this project that you referred to, Genome in a Bottle. It's there when I started to think about how can we take the stuff that we've learned in researching DNA and how to test DNA, how can we take this stuff and translate it to something that folks could use? And back then, I'll tell you that these advanced sequencing and DNA testing methods were not being used in medical testing. They were really research tools. And at the time I was wondering, what does it take to get it from the research environment to a clinical lab? And one thing that's really important in medicine, but also in forensics and in really any translational space, is that when you build technology, you have to be able to benchmark it and performance test it. So if you're going to claim that you can measure a diagnostic marker, you have to be able to show that you're able to detect the marker properly. And, what is the error rate, all that kind of stuff. And so that's kind of how we got involved with Genome in a Bottle, which was a government project run by NIST. And they do a lot of work in benchmarking and developing reference materials and standards to compare methods and kind of performance test how technology really works. And so I had left the university to start a company. It was a company called Arpeggi. Our goal was going to be to basically translate the cool things that were happening at the university into something that, again, could be applied to the clinic and deployed to real life people that have real problems in the real world. And I say that kind of in jest. I mean, research is important as well, but I particularly wanted to translate this technology to the clinic. And so we worked in my first startup, Arpeggi, with NIST, and we helped build a platform to basically performance test using the reference standards that the government had made, performance test how labs could do their testing. And so what ended up happening is private labs, university labs would use our toolkit that we built at Arpeggi, and they'd use our toolkit along with these reference standards from Genome in a Bottle to basically prove and validate that they could, correctly produce clinically important information. And so it's a really cool project. I enjoyed being part of it. And it was kind of my first experience in translating some of the amazing stuff that happens at the university into, again, something that a private company could use to bring some kind of clinical value to folks.
So that makes me think that with that application, you were really sort of in the field of using that technology for medical purposes, whether, cancer research or prenatal abnormalities or something like that, right? Like in that vein, in the medical vein?
Yes. And again, I trained at Baylor College of Medicine. So my early exposure to science was all biomedical in nature. And so although I have broad interests, my training and my career until very recently has been primarily biomedical research and in clinical diagnostics. So I definitely came from more of the medical side of things.
Gotcha. What does Othram mean, or why did you choose that name?
Othram is it's an inside joke. Some of our folks on our team are Lord of the Rings fans, and Othram is the wall that basically protected the city from outsiders. And so it kind of has a inside joke quality to it, given that we have some Lord of the Rings fans here at Othram, but also kind of the idea of being able to protect society. And perhaps one of these ways that we do that is by helping work through crime scenes and identify responsible parties to crimes, help identify victims that may not have identities and bring them back to families. So both an inside joke due to the interest in Lord of the Rings, but also kind of a play on the idea of protecting and guarding society.
Well, that is a great explanation, and I'm glad I asked because that leads into my next question, which is why did you decide to switch from medically focused or clinically focused research and work into the criminal justice forum? Because like you just explained, Othram helps solve crimes and helps identify nameless. What made you switch and dive into that field?
Continuing on from that story about Genome in a Bottle and my first startup, that startup was acquired and we went on to do a number of things, mostly, not all, but mostly in the clinical space. And so the technology has just really exploded. And a few years back, it occurred to us that this technology succeeded. It's penetrated most of the clinics. You can get a test to measure some genetic marker for a clinical disorder or a risk or something. There's probably a clinic on every street corner that can help you kind of get the information you need to diagnose or to learn more about a medically actionable DNA marker. But one area where I feel like DNA testing hadn't really been used at its potential is forensics. And so that's an area that's really interesting to us because there's a huge value. You can imagine the societal value of being able to help work crime scenes, but yet where do you go? Where would you go to do that kind of work? And when we got involved in it, there really wasn't anywhere to go. And to this day, we're the only laboratory in the United States that does this work in-house in a forensic way. People will sometimes work some of these projects through outsourcing to other labs, and not all the labs are forensic labs. And there is nowhere to really go to do this. There's no forensic lab you can go to do the kind of work we thought would be most valuable for forensics. The forensic system that we have now is very powerful to this day, but it was conceived 30 years ago using technology that was available at the time. And we tried to reimagine if we could build the forensic lab of the future, what would it look like using technology that's obviously advanced in the last several decades? We envisioned that, and then we decided, let's go give it a shot. Let's take a risk and try to build that because, again, this just seems like an area where there's tremendous need. The National Institute of Justice calls the unidentified cases, they call it a silent mass disaster, accumulation of remains that are found, not even crime scenes. I'm not even talking about looking for perpetrators in a crime, just the sheer number of unidentified remains that are accumulating because they are not being identified using traditional forensic tools, and they just sit there unidentified for eternity. So this gigantic scope of problem that's there, and yet, again, nowhere to really send these things to do something beyond what is traditionally used in forensics. So that kind of was our inspiration. Just felt like it would be like a really cool humanitarian benefit using DNA technology that we've already worked on for decades. I mean, I started working on this, over 20 years ago, and the people on my team have all had similar backgrounds to mine. It's not just me. It's, 20 of us that have spent decades or more working on DNA testing, but just seeing if we could repurpose it to an area, again, that's underserved, but there's a need and has a really huge value and societal benefit. So anyways, that's what we wanted to do. And so a few years ago, we all kind of dropped out of what we were doing and built from scratch a laboratory, identified a space and tile by tile, built a brand new space fabricated from scratch that represented what we thought would be the forensic lab of the future.
I heard there's not even a drop ceiling there.
We have a ceiling. We re-engineered everything in the space, though, including the HVAC system. I mean, there's a lot of components and pieces to build when you build a lab like this from scratch. We have lots of different rooms and subrooms and isolated areas to look at evidence, to prevent cross-contamination of one piece of evidence to another. There's so much infrastructure that goes, temperature-controlled spaces. The machines that we run operate under very stringent parameters. So even building like local infrastructure to basically support like perfect environmental variables so we get the best data. There's a lot that goes into building this. You can't just rent an office space and throw a machine in there and go for it. There's a lot that goes into this, and it is substantially different than what you would need to do if you wanted to build, let's say, a research lab or even a medical sequencing lab. If you build a medical lab, you have fresh DNA coming from, living folks that have plenty of DNA to give, high quality, high quantity. That's a different kind of testing experience than when you're working with trace amounts of evidence that are really not in great shape and suboptimal condition, and certainly very, very scant quantities.
Hey, Streetwalkers, here's a word from our sponsors.
Texas has a reputation for being tough on crime, but beneath the surface, buried in the darkness that only those affected by tragedy know, is the reality of a flawed and insufficient justice system. More than 60% of violent crimes in Texas go unsolved, and many are at the hands of offenders who should have never had the opportunity, madmen who slipped through the cracks. On Gone Cold Podcast, Texas True Crime, you'll find in-depth accounts of unsolved homicides, missing persons cases, and other mysteries throughout Texas. From the historic and perplexing case of the 1948 disappearance of a Denton co-ed, Virginia Carpenter, to the unthinkable, the Orange, Texas abduction and murder of 4-year-old Denaria Finley in 2002. You can find and subscribe to Gone Cold, Texas True Crime, wherever you listen to podcasts.
Let's get back into it.
Was there a specific DNA or genomic breakthrough that made what you're doing possible? Like, was there a specific marker that you can, remember that, oh, okay, well, now this is possible, that opened up the possibilities even more?
There's not necessarily a specific marker, but we basically vertically integrated step by step an end-to-end process that just approaches each aspect of DNA testing, from the extraction of DNA, enrichment of the human component, and then the eventual sequencing and measurement of markers. We vertically integrated that process specifically for forensics. So building something that is tuned and optimized just for forensics, I think that alone represents a huge advancement over what's being done before. We're just trying to repurpose. Sometimes people are repurposing recreational DNA testing tools to use on forensic material, and sometimes it works, sometimes it doesn't. So I think that alone would have been a breakthrough. I think other breakthroughs include the decreasing cost of the technology, right? Technology can be useful, but can also be too expensive to be feasible. So there's the decreasing cost. And then there are some specific innovations that we've made and are continuing to make that allow us to push the limits of what we can do in terms of accessing information from evidence that would be, previously considered unusable. And so, we have also added innovations, and I don't want to downplay that, but I think a lot of the magic comes from being able to fine tune a process. When you own a process, when you do the process yourself in-house, you can tweak every step to be maximally beneficial for the kind of DNAs that you're working with. And then the last thing is, you don't want to overlook, there's tremendous software here requiring a lot of compute power to basically piece together the fragments of information we get. Because when you do these kind of DNA tests, you're accessing tens of thousands to hundreds of thousands of markers that have to be like reassembled in some resemblance of a person's genome. And then you use that information to do, relationship testing and find relatives or learn something about that DNA. And I can tell you that forensic samples are imperfect. They're usually degraded. They can be contaminated. Sometimes they're mixed. So there's multiple people in the mixture. And all those things introduce noise and error into the data. And if you don't have good software process to remove that noise, and that kind of goes back to the genome in a bottle thing, right? If you don't have the right tools available to kind of clean up that data and get a very clear, accurate representation of the DNA markers from the unknown person without contaminating, like I said, noise, error, other stuff, then the process doesn't work very well. The whole premise of relationship testing is that if two people share a lot of DNA, they're probably related. If the person that you're looking for an identity for, if you build that person's profile and it's full of noise, they're not going to look related to anyone. So you'll have what scientists commonly call the false negative problem. You won't see the matches. So there's just a lot. You're integrating the talents of computer scientists, lab scientists, and engineers to basically build something that is cost-effective, scalable, and then scientifically and computer science-wise accurate and, lack of a better word, correct. And so all that together is, I think, what enables us to take on these projects that have just not done well at other laboratories or with other methods.
Gotcha.
That's probably more than you want to know, but that's
not at all. That's perfect.
Really the best answer. It's not one single breakthrough and then all of a sudden we're good to go. It's just a lot of blood, sweat, and tears, iteratively working to build the most perfect process possible for forensic evidence.
Okay, so I know that your company did not work on the Golden State Killer case, right?
No, that case was executed by a very cool crew of folks. That was Paul Holes from the local law enforcement side, and then Steve Kramer from the Bureau, and then Barbara Ray Venter, who's an amazing genealogist. And so there was more people involved, of course, but those were the three key players that worked that case.
So the reason that I bring that up is because I think that is probably the easiest way of going about explaining what it is that Othram does. So the Golden State Killer was unsolved. It was a killer and rapist that was unsolved for 40 years or whatever. And they did have DNA, but his DNA was not in the system. So what they did was they built a profile, and they were able to link that profile to a number of people and narrow it down, through relatives and genealogy. And then they were able to find the guy. Is that about right? And that's kind of what you do. Not kind of, that is what you do.
Yeah, Othram was not involved in that investigation.
Right.
But yes, they were able to search genealogical databases and uncover a relative that led that team that I mentioned to you to a possible candidate. And then they used traditional forensic methods to prove that, in fact, this is not just a candidate, but it really is a suspect of this crime. And then, obviously, he went through the court system, and I believe he ended up reaching some kind of deal in which he ended up confessing to the crimes.
Sure. So that's what your company does as well. And you did it most recently and arguably most notably with the Carla Walker case that I mentioned at the top of the show. How did you get involved with that case? Did law enforcement bring it to you? Is that something you sought out?
Yeah, that's a good question. So I mentioned Paul Holes. He was one of the team members for the Golden State Killer case. Paul Holes did a TV show called The DNA of Murder, and it aired, I believe, on the Oxygen Network. It was earlier this year. I think it aired in April. And he had these 10 episodes, and he highlighted these 10 cases. And one of these cases, I think it was episode 9, was the murder of Carla Walker. Right here in our backyard. We're located in the Woodlands. We're about 3 hours from Fort Worth. And I hear about this case for the first time from this show. And I know Paul. I've talked to him. He's a really great guy. And we had kept in touch. I mean, this is not a huge field with a lot of players. And so we knew each other. And so I talked to Paul, and I told him, I said, I'd love to help. And he said they had already tried some methods, I think earlier this year before the episode aired. And when they did the testing, it didn't work. The DNA wasn't good enough. I don't remember what the reason was. I wasn't involved in the testing prior to coming to us, but I think they had mentioned it was too degraded, or for whatever reason, it wasn't suitable. And I told Paul, I said, I'd like a chance to look at it. And I told him what I told you, is that we have re-engineered every part of the DNA testing process to maximize the chance that we can get useful information from even the worst evidence. So I want to take a look at it. And this case meant a lot to Paul. And so he reached out to the Fort Worth detectives, Leah Wagner and Jeff Bennett, and connected us. And I talked to them, and I think they were understandably skeptical at first. They had just been through a testing process. And my understanding is they ended up consuming most of the evidence in this case using this other method that didn't work. And so I think they were apprehensive, but luckily enough, they were open-minded and also only 3 hours away. So Leah Wagner and Jeff Bennett, they drove down and came to my lab, and I walked them through the lab, and I sat down with them in person and kind of explained to them what we could do and where I thought we could help. And we're grateful because they gave us a chance, and we went on to work the case with them.
Now, listeners, that Carla Walker story was the 9-part series that kicked off the incredible podcast Gone Cold. You know about it. I talk about them all the time. If you're unfamiliar with it, start there, because that is the case that made the Gone Cold people want to do a show about unsolved crimes, or unsolved murder specifically. So definitely check that out. Now, you did mention that some of the DNA might have been destroyed during the process of other labs testing. Does your process destroy the DNA samples?
Yeah, so that's a great question. When you test DNA, when you do something to it, it's not to say you're destroying it, but you're consuming it. So yeah, you can only test DNA a finite amount of times. Now, something that really separates what we're doing is that we've designed our process to work on minuscule amounts of DNA. So whereas other methods will require more DNA, certainly methods that are adapted from consumer testing or, medical testing where you have expectations of lots of DNA, what we do is we take minuscule quantities of DNA. And so we do consume DNA just like everyone else. But what I like to tell law enforcement is you can test with Othram and live to test again. We rarely have to consume all the evidence in a case, and you would never want to do that. So this is a good point that you bring up, because even if you have a lot of evidence, like why consume more than you need? Who knows what you'll need to do in the future, what other tests you'll need to perform. So we focus on not just bringing value and accessing evidence, but we focus on doing it by consuming the least amount of evidence possible. And so that's another big differentiator for us.
I know that what you do is different from Codis, but can you explain in what ways or how it's different?
Yeah, that's a great question. So Codis is a database system that the Bureau developed, still a very powerful system and really the first line of action when you work a case. And the way it works is that you capture 20 markers in the DNA. You'll say you commit a crime in Dallas-Fort Worth area. And so if you're convicted of the crime, they can capture these 20 markers from your DNA, put you into Codis, and perhaps a couple of years later you relocate to San Diego and you commit another crime. Now you're in Codis. And so when they measure the 20 markers in the crime scene, they should be able to match it back to you and basically say, look, this is a repeat offender. This is someone that committed a crime in Dallas and now committed one in San Diego. That's how Codis works. And the power of Codis is that you can very accurately track and quickly track repeat offenders, the crimes that they commit anyways. The downside of Codis is that if you're not in Codis, it's really hard to find you. And if you're not a convicted criminal, you're not in Codis. So, in the case of Carla Walker, they used Codis. They tried to use Codis to see if the DNA from the unknown male could be matched to anyone. And there was no match, because the person that committed the crime had not been convicted of a crime. And I have to tell you, sometimes there are situations in which, people are convicted of crimes and they still don't end up in the database. It's not perfect. But anyways, that's kind of the way Codis works. What we do is different. What we do is we capture tens of thousands to hundreds of thousands of markers. So this isn't 20. This is like tens of thousands to hundreds of thousands of markers from DNA at a crime scene. And we can use that information to learn a lot more. We can understand biogeographical origins, ancestry, and then we can take that and use it in a search to find relatives. And I'm not talking about the kind of folks that you have over for dinner on Friday. Like I'm talking about like distant relatives. In a sense, we're all genetically related. So you may have a third or a fourth cousin. You may not know who they are, but if they're genetically a match, genetically similar, so to speak, then we can identify those relationships, very distant relationships. And if we can identify enough matches, we can start to piece together from public records, from marriage records, birth records, we can start to piece together a family tree. And as we put the family tree together, if we know who the matches are to an unknown person, and we know how related or not related they are to the unknown person, then the tree can be constructed, the matches kind of form the scaffold, and then the unknown person, we can kind of figure out a limited number of ways they can fit onto the tree as well. And as we begin to place them on a tree, what emerges are essentially candidates for who that person might be. It sounds complex, but this area of records research and finding, relatives and ancestors, this is something that's been around for a couple decades. And it's a really interesting, a whole other area of investigation worthy of its own discussion. But, to summarize, we can use that information, and whether you're specifically in any database or not, just through the ability to identify relatives and build trees, we can figure out the identity of someone either that is unidentified, like maybe a victim that no one knows who the victim is, or we can identify perpetrators to a crime if they have left their DNA at the scene.
Gotcha. So a super dumbed down version, could I say that Codis connects the dots and Othram makes the dots?
Here's how I would describe it. I would say Othram is really good at finding people, and I would say Codis is very good at confirming.
Gotcha.
So Codis is the gold standard. It's the best way to confirm identity. And this is what happened in the Carla Walker case, is ultimately the investigation led to an individual being identified as a suspect. But guess what? He was confirmed using these markers that are used in Codis. And so I think the way to describe it is this, is you use Codis, and sometimes you can find someone. If you can't find him, you go to Othram, and Othram will generate candidates to help you find the person you're looking for. And then the Codis markers are used to essentially confirm that the person you identified is in fact the one you're looking for. So they kind of work together. One is to find and one is to confirm.
That makes sense.
Now, I do want to point out that the work that Othram does to generate this information, these are leads, right? The Carla Walker case wasn't built on Othram's information alone. The way this investigation works is that there are no candidates and there are no kind of leads that are left to explore. And so the testing we do produces identifying information that might lead to a candidate for a suspect. So not even a suspect, just a candidate possibility. And then that information goes back to law enforcement, and then they overlay that with the information they have in their investigation. In the case of Carla Walker, information we gave them led them to narrow in on someone that had early on been a person of interest. And even then, you haven't actually figured out the case. At that point, then, you do confirmatory DNA testing, like I told you, using Codis markers. But you never make a decision exclusively based on this information. This information is a lead. And so it's only after you've overlaid it with the entire investigation and then you've gone on to do confirmatory testing before you even begin to get to the point where you could say, I have a suspect to this crime. Hopefully that makes sense.
It does. It absolutely does.
Hey, Streetwalkers, here's a word from our sponsors.
If you'd like to help find answers for the families of unsolved crime victims from all over, or perhaps identify a Jane or John Doe, please visit DNAsolves.com, where you can submit your DNA from a consumer testing company like Ancestry or 23andMe to their database. DNAsolves.com.
Let's get back into it.
Now, I know that you have a database, right? Let's talk about DNAsolves.com.
Sure.
What is it?
So there's two parts to DNA Solves. One part is we have a database, and if you are interested in helping us identify unknown persons, so these are like the unidentified remains that will remain unidentified indefinitely unless someone does some kind of advanced testing, or if you want to help perhaps solve a crime by identifying a suspect that might be a perpetrator in a crime, then if you've tested with a consumer testing company, you can contribute your data to that database. And the database is used for nothing other than law enforcement investigation. So if you don't want to help a law enforcement investigation, then you definitely don't want to participate. But if you're interested in helping law enforcement either identify an unknown person or help catch someone that might have perpetrated a crime, then DNA Solves is a great way to do that. It's very easy. You can go in there, log in, upload your data, and then your data could be used to help match and find the next person. That's one side of DNA Solves. The other side is we have some campaigns that we do. They're on the landing page for cases that we're trying to work. Suppose there's a case that you find interesting, or maybe you just really like what we're doing and you want to help out. We have two ways that you can help out besides contributing your data. We have ways for people to contribute money towards a specific case that they find interesting. And we also have a model where people can just kind of subscribe. Some folks will just chip in a few bucks each month, and that money gets, if it's subscription-based, gets divided among any open case that we have, and then is used to help fund those. And usually we fund these cases through a combination of crowdfunding. Sometimes we get like private donors. We've had a variety of ways that people, when they hear about this case, they get involved. That's actually the other hidden benefit, by the way, is that when we talk about these cases, it just gets the word out. And then you never know. Someone might have a tip or a clue, and that's another way to help solve these cases. It's not about solving using only one method. You just want to use every method available. That's kind of what DNA Solves is. It's one side is the database that you can upload data to if you want to help identify a person of interest in the next law enforcement investigation. And the other side is kind of the funding arm that we use for cases that can't get funded through traditional means. And I'll tell you, the vast majority of our cases are basically just done directly with law enforcement, funded by law enforcement. But there are some cases. There's some cases, sometimes it's an unidentified remains, and there either isn't funding or there's no easy way to get funding for this case. But through the support of the public, we can work the case anyway and help bring in answers.
This is sort of maybe a difficult question to ask, but is there an approximate or average cost that it takes to, I don't want to say to solve a case, but to run these DNA samples through your technologies?
Well, the general budget for a case is going to be probably around $5,000. So yeah, it's not like it's going to be like tens of thousands of dollars, and these $5,000 that we use to drive a case ends up being the vast minority, I would say, of the cost of a total investigation. You can imagine, an investigation can be quite expensive. Anyways, every case is different, right? And we've had cases that have been more expensive, but I don't like to have variable costs. So we decided that we were just going to cap it at $5,000. And there have been some cases that have costed more, but generally we can complete an investigation with law enforcement at a top line budget of $5,000.
Gotcha. Now, back to DNA Solves. You mentioned that if people have already submitted DNA testing or whatever through other companies, what are some of those other companies? Like, what would that be?
So maybe you tested at Ancestry.com or 23andMe. There's a number of companies that are consumer-facing companies that can test your DNA and tell you something exciting about your ancestry, who you're related to. And those companies will allow you to download your raw data if you want, the representation of your markers, so that you can then, search other places for more relatives. DNA Solves will not help you on your genealogy journey. It's only available to law enforcement. But for those that feel like, they want to make a difference, again, this is an opportunity for them to kind of jump in and contribute their data. You never know. You could be distantly related to someone that's still waiting to get their name back.
Now, is DNA Solves at a point where, like, I could request you to send me a kit and then I send you my DNA and you do all that heavy lifting? Are they at a point to that yet?
Yeah, so we will launch a program in the new year that allows people, if they've never tested at all, to test with us. In 2020, we predominantly were just simply going to folks that had already tested and saying, hey, toss your data in if you want to help. But yeah, we'll launch our own program. I mean, obviously we have a laboratory, so we could perform the testing in-house, and we'll probably launch a program like that early in the new year. I don't have the exact details yet, but if someone wants to participate, but they don't have DNA data, then obviously we want to find a way to make that possible.
Gotcha. As far as you know from all of your experience, what do you think the biggest reason that somebody would not want to upload their DNA?
Your DNA is yours, and people are always concerned about privacy and, how the data will be used. I think these are not questions about DNA. These are kind of general questions you ask about everything. It's like, why do some people do online banking, but some don't feel comfortable? And why will some people share information on Google services and others will not? Like, there's this kind of balance between wanting privacy, but also wanting to get benefit or to do something good. And balancing that and building that relationship of trust with folks so that they give up a little bit of information, but they get something back for it. And in our case, what you're getting is the ability to bring to conclusion a positive outcome for cases that might have been stalled for decades. But I think just a concern about how that data will be used. And that's one of the big reasons why we built our own forensic-only lab and why we limit the use of the database just to law enforcement, because I wouldn't want anyone to think that we're going to do medical research or anything else. There's no medical component to what we do. We don't give people's DNA away to anyone. It's all done in-house at our facility and done with the exclusive purpose of trying to identify someone from a crime scene. Now, some people feel like that may not be a good use of their DNA, and that's fine too. I think, you should be voluntarily interested in doing this. And if you're not, then don't. There'll be some people who just fundamentally disagree with the approach, and that's fine. There's others that want to learn more and be assured that their data is safe and so on. So I really feel like this is a personal decision. I don't like to pressure people, but I do like to make the option available to those that want to participate, either to upload their DNA or get tested up front. I think every person that helps, it just moves us closer and closer to clearing out more and more cases.
Now, let's just say, for example, that I uploaded my DNA to DNA Solves, and you were able to find or identify a person or a perpetrator or whatever with the help of my specific DNA. Do I get a notification that says, hey, man, good job, way to go, thanks?
You laugh, but it seems like an interesting way to incentivize and reward people so they know. I like the idea. It's not something we do right now because we simply provide the genetic facts and information to law enforcement, and they're the ones that are doing the investigation, right? So we're not really in a position, we don't want to be in a position to where we're disseminating information about a case, even if it's something like what you mentioned. If there was a way to do that in the future that was kind of in alignment with law enforcement, like I actually think, a lot of people have asked about that. I think it's interesting. It'd be cool to know if you were able to help solve a crime. But yeah, right now, we really have a one-directional system. We pass information to law enforcement, and then we just stay out of their way, and we let them do their investigation. And then obviously we celebrate with them at the end when there's a positive outcome.
That makes sense. Your database sort of reminds me of like the Neighborhood Watch program.
It is. It's like the genetic neighborhood watch. But, it's different because even in the case of like a neighborhood watch program, a neighborhood watch program is more like surveillance, right? Like you're looking out every night to see if someone's kind of entering your neighborhood. And these neighborhood watch programs have been very effective, but they're fundamentally based on surveillance. The kind of work we do, I really like it because it's not surveillance and it's not forward looking. It's always looking into the past. A crime's already been committed and we're just trying to retrospectively try to figure out what happened. But I guess in the same way that as part of a neighborhood watch program, you could provide a tip to someone, we're in a sense providing a genetic tip. We're kind of pushing the investigation forward by providing a clue or some kind of tidbit of information that helps law enforcement push past a barrier and help them kind of narrow in a little bit further. I mean, that's really what we do. Is our goal is to eliminate possibilities so law enforcement has fewer and fewer things to consider. And then from that perspective, I think that's why I was telling you, like a $5,000 budget to narrow a lot of possibilities could be very cost effective. You could imagine how much time it might take. Imagine how much money has been spent on the Carla Walker case or in any of these cases. If you can save a substantial amount of time by doing an advanced DNA test, that's, I think, very cost effective.
I think so too. And time. Time is always of the essence, especially when things like that are.
It is of the essence. I got to tell you, like in sex assault, unfortunately, sometimes these crimes are, and not even sometimes, commonly, these crimes are serial in nature. And so figuring out who's doing something is of value because you could quite literally prevent future crime if you're able to identify who's responsible. But even if you don't, just being able to identify who they are, we worked a case where we identified someone that had perpetrated a sex assault homicide. And as it turns out, in this other case, this is not the Carla Walker case, but in this other case, the gentleman who's now deceased, he was involved in the assault and murder of other people. And so it becomes even more cost effective because you've spent an amount of money to work one case, but then in doing that, you've actually knocked out a few other cases along the way. And so the benefit in terms of being cost effective is there. And then obviously the benefit to society if, God forbid, you could identify someone before they perpetuate another crime.
Well, I'm glad you brought up a violent sexual crime. A previous guest of my show named Josh Scheinblum, who's an investigative journalist and worked with Katie Couric on an Emmy-winning story for CBS about the nationwide problem with the backlog of untested rape kits. Is that something that your company can jump into? Are you involved at all in any of this?
Yeah, we are. And so here's the thing. There's this goal to end the backlog, right? These are sex assault kits that have been sitting untested. And the argument is if you test them, you might discover who some of these perpetrators are. So there's been this end the backlog push to, kind of clear out all these untested sex assault kits. And sure enough, as they started testing them, they have identified in a handful of cases folks that perpetuated crimes. But here's the thing. Here's an important statistic for you is I believe the identification rate through Codis for these sex assault kits is 15%. That's 1.5. So 85% of the time when you clear that kit, when you run that kit, you don't necessarily get the identity of the person that perpetrated the crime, right? So It's important, I think, for the public to know that clearing the backlog is not the same thing as solving the backlog. It's critical to clear the backlog, but clearing the backlog, ending the backlog doesn't solve the backlog. And so what's going to happen is you'll end up with a new backlog of cases that have been tested, but in fact, although being tested did not lead to a positive outcome, to a successful identification of who might be responsible. And so it's in those cases that we've jumped in now on a few different publicized sex assault homicides where we've been able to identify who the person was, even though Codis failed to do so. That includes Carla Walker. That includes another case that we worked directly with the Bureau, the rape and murder of Siobhan McGinnis. She was a 5-year-old in Missoula, Montana. And even another case in Canada that we worked, the Christine Jessup case, a 9-year-old that was raped and murdered. And again, perpetrator not identified. In that case, they actually identified the wrong person. And he was exonerated when the early forensic testing that we use now was just established in the 90s. But in spite of being exonerated, they never found who actually did it. And we were able to help the Toronto Police Service figure out who is responsible in that case. So, and we have other cases too, but those are 3 that come to mind that have been announced. So there's going to be a good number of cases where they've done everything they're supposed to do. They've cleared the backlog, they've tested the case, but they don't get an identity in Codis. And if they don't get an identity in Codis, I don't want anyone to give up. If you can't figure it out with Codis, then it's like I told you, go get the finding information from Othram and then go back and confirm it with Codis.
Is there a chance or a possibility that there could be a database built just using the rape kits?
Well, there is a database built with the rape kits, and that's Codis.
Well, there you go.
That's why I'm saying Codis is valuable, because Codis is already indexing all of these crimes. And so, for example, in the case of Siobhan McGinnis, we helped law enforcement identify who's responsible. Then guess what they did? They now tied his identity to the Codis markers in that case. But then they can also cross-reference other cases that came from those same Codis markers. And now they're able to link, because we've helped them identify who the person is, that person to other cases. Does that make sense?
It absolutely makes sense.
So even if Codis can't identify who someone is, what you can do with Codis is you can say, I don't know who this person is, but he's been involved in 2 crime scenes, 3 crime scenes, 4 crime scenes. And so when you eventually do identify who he is from any of the crime scenes, you've in effect identified him in all the crime scenes now.
And then Codis connects those dots.
Codis connects the dots between the repeat crime. And that's really what the magic of Codis is. The magic of Codis is in being able to connect and track repeat crime.
A few weeks ago, a different podcast, one called the Shocking Details podcast, did an episode about a hiker that was found dead, and he is known as Mostly Harmless. It is my understanding that you and your company are working on that case or are involved with that case. Is that right?
Yeah, we are. That's an example of a case that we crowdfunded on DNA Solves. We literally funded that case with the crowd because there was enough interest, and we're now working that with law enforcement.
So that's still in process?
What I can tell you is in that case, there's a candidate that's been identified, and we're right now in the midst of doing DNA testing to confirm, essentially a confirmatory test to confirm the identity of who he might be. So I think that case is at the very end, and I think will soon be announced.
Oh, very cool. I did have a question about how does adoption play a role in this whole process? Like, my dad's adopted. So if you were going to try to connect me ancestrally to me through other people, like, does adoption just make it exponentially harder?
It does. There's a whole bunch of situations. You may have a scenario where someone's dad, they're reported as their dad, but they're not really the dad. Maybe they're on the birth certificate, but they're not actually biologically the dad. You might be an adoptee and your parents are not your biological parents. So then what ends up happening is you work many cases at the same time, right? Because if I have an unknown person that matches to you, and you're an adoptee, then I got to work your case and I got to figure out who your biological parents are. And then after I do that, I go back to looking at the unidentified. So there can be a lot of interesting twists and turns. People always ask, how long does a records research take? Well, this is one of the many things that can influence that, along with how many matches you even get, all that kind of stuff. So yeah, it can be a wild ride sometimes, but a rewarding one.
Yeah, I bet. In addition to being the CEO of Othram, you are editor-in-chief of something. What is it?
Again, back to your point about, wanting to make sure you can validate and build out technologies. I really think, again, like my heart and my original beginnings are from the university. And I think that's where a lot of the amazing research will continue to happen to drive this technology forward. And so Marianne Liebert, she's a big publisher of scientific journals. This is where people in the university will publish their cutting edge research and have it reviewed by members, peers in their field. And, these publications of scientific research is how basically science marches forward. And so Marianne Liebert took an interest, and she's done a lot of genetics and genomics focused journals. And she really wanted to capture a journal that covered this area. Obviously, I love this area and I've committed myself to it along with my team. And so they asked if I would be the editor in chief of this new journal. And I jumped at the opportunity because the more we can do to share the success stories, to help drive research and interest in this field, the more quickly the technology will be adopted. And again, there's hundreds of thousands of cases that need to be worked. So anything that can move that along, I think, is a worthwhile effort. And so being the editor in chief of that journal is kind of my other way of trying to help drive the discussion and the research around this topic.
Well, it seems like you're a very busy man. Speaking of which, when my mom was, 15 or so, I don't remember if she was diagnosed with Hodgkin's or non-Hodgkin's lymphoma, but either way, she had some experimental cobalt treatment that saved her life.
Oh, wow.
Courtesy of MD Anderson. Mm-hmm. That cobalt treatment they don't use anymore because she ended up dying at 58 because of the complications stemming from that treatment. It weakened her organs and blah, blah, blah. But MD Anderson did save her life when she was 15, and that let her live not only to be 58, but also to have my sister and myself. So it is with great respect that I ask you, what are you doing with MD Anderson?
So, I told you I trained at Baylor College of Medicine.
Yes.
Baylor and MD Anderson and UT Houston and a couple other schools there, they form what's called the Texas Medical Center. It's the largest medical center in the world. Again, I'm biased because I came from that place, but I got to tell you, it's an amazing medical center. So MD Anderson, they have a training program for medical technologists. And these are people that are going to essentially become the army of folks that deploy genetic technique across labs across the country. And they have had the foresight to realize that in addition to clinical diagnostics, there are other applications to genetics, including this idea of using DNA testing in the way that we use it to advance law enforcement investigations. And to their credit, even though they're traditionally a medical school, they wanted to incorporate that curriculum into their training program for genetic technicians, these scientists that will go into the laboratories and do advanced DNA technique. And so again, much like the journal, I find that fascinating, right? Because you need technology. You need to study the technology with these scientific journals. But look, at the end of the day, you need real human beings to actually go do the work. And today, we've learned as we go along, but I think in the future, there'll be training programs, advanced DNA testing courses that integrate into traditional forensic curriculum. And the fact that MD Anderson wanted to kind of pilot that program, people from MD Anderson, the students can literally come to Othram and rotate through the only lab in the country that does this work in-house right now. And they get kind of an inside look at how the testing works, and they get to follow analysis from start to finish. I think it's fascinating. And actually, we've been talking to other universities, and we're very university friendly. So we've got other projects in the works with other universities. I think that what you see at MD Anderson is just the beginning. Eventually, there'll be, entire curriculums and maybe even, majors in these kind of forensic genomic fields. Maybe in the future you could actually major in forensic genomics. It's a whole field of its own. This is what the journal's called, forensic genomics, whole field of its own that will leverage the entirety of what we know about genomics and DNA testing to help take a law enforcement case to completion. So I think it's fascinating. I'm obviously thrilled to be working with folks that I train through. And I think MD Anderson, is the best partner we could have picked for. I have to say, rather they picked us, but they're a great partner to pick for developing these training programs.
That's amazing. David, as we're heading out here, can you tell everybody where they can go to submit their DNA if they want to help be a crime fighter?
Yeah, if you want to help us with the case, you'd go to DNA Solves. So it's DNA, SOLVES, DNAsolves.com. And there's a lot of things you can do. If you see a case that interests you, just share it. Spread the word. Let people know. Just sharing information is already a great way to kind of get the word out. And if you want to make an account and upload your own data, that's great too. It may help identify and create a break in a case in the future. like I said, we'll soon launch a way for you to even request a DNA test directly from us if you want to do that. And then the last thing you can do is, as I said, we're always crowdfunding for cases that have kind of fallen through the cracks or can't get funded through traditional means, like that hiker case. So we encourage those that are able and interested to contribute to one case. You can subscribe for a few bucks a month just to get advancement on all our cases. And, if you subscribe, we do like a monthly update, kind of show you how your funding was used to work cases. It's kind of like what you asked about with the DNA profile. But, like I said, it's a little challenging to do that right now. It's very easy to show someone if they contribute $5 how that money is broken down and what cases have benefited from that. So yeah, whether you choose to subscribe or donate or add your DNA or even just spread the word, there are a lot of ways to get involved. I think all of that together is going to make for a really great 2021. There's just so many cases to work. I can't stress that enough. And so there's a lot of things that'll have to go in to helping us scale so that we're working, tens of thousands of cases and bringing this value to everyone's investigation and not just to say, a notorious serial killer. This is technology that should be deployed for all cases. And that's kind of our mission.
Again, guys, that's DNAsolves.com. Go there if you want to help out in any of those previously mentioned ways. David, where can people find more information about you? Are you on social media or anything?
I am. Not a lot, but the easiest way to keep up with us would be on Twitter. We do post updates on Twitter. The handle that you would look for is Othram Tech, OTHRAMTECH, so Othram Tech. Again, I actually post updates on DNA Solves as well. So I think Twitter, Othram Tech, DNA Solves, and then we have some discussion groups on Facebook here and there. But I think the first two options I gave you would be probably the best way to get information about us. We try to spread the word as best as we can, but our primary function is a laboratory that serves law enforcement. So generally, other folks in the community will share the news about what we're doing or cases we're working on. But yeah, DNA Solves and Twitter are probably the best way to keep track of what we're doing.
Gotcha. Now, everybody, if you want to know more about the dead hiker known as Mostly Harmless, which should be solved really soon, I think, you can check out the episode pertaining to that fellow, the Shocking Details podcast. And I highly recommend the 9-part series that jump-started the Gone Cold podcast. That really gives you a hell of an introduction to not only what the podcast is, but about what a terrifyingly difficult process it's been for 40 plus years to help solve this murder. And again, David, well done on that, by the way, man. That is amazing. It's so huge. David, before I let you go, is there anything we didn't talk about or I didn't ask you about that you wanted to talk about today?
No, I think we covered everything. Just to kind of remind everyone that these projects are massive team efforts. So these investigations work because there's just massive cooperation between law enforcement, between the crowd, even different agencies in law enforcement. And then you sprinkle in a little bit of technology from Othram and you put it all together. And it's amazing what can happen when you have huge teams of folks working together towards a common end. That's what happens in a lot of these cases, is it's usually not one thing. It's the combination of all these pieces that come together. Just very excited about that and very optimistic given how much public support we've seen this year. Just very optimistic about what we can accomplish next year.
Nice. Well, David, on behalf of me and all of the true crime, I'm not true crime, but on behalf of all of the true crime podcasters and podcast listeners, thank you, David, and thank you to your more than 20 employees at Othram who helped bring some closure to these families and some names to these unknowns. Thank you.
Yeah, I appreciate it. I will tell you, the team isn't on social media very much, but they are aware. We listen to podcasts. We watch the case announcements when law enforcement announces a solve, and they're always very appreciative of the comments and the feedback and everything else. So I'll definitely pass the word to the team, and they're the ones that do all the hard work. So I really appreciate that.
Absolutely. Thank you so much, man. You have a great week.
You too. Bye.
Bye-bye.
If you'd like to help find answers for the families of unsolved crime victims from all over, or perhaps identify a Jane or John Doe, please visit DNAsolves.com, where you can submit your DNA from a consumer testing company like Ancestry or 23andMe to their database. DNAsolves.com.
As always, thanks for listening, Streetwalkers. And don't forget, follow the show on Twitter at FascinationSTPD, on Instagram at Fascination Street Pod. Follow the podcast page on Facebook at Fascination Street Podcast. And of course, you can always email me at fascinationstreetpod@gmail.com. And if you haven't already, don't forget to hit the like and subscribe button and rate us on iTunes. Opening music is the song Magnolia from the 2014 album Intransigence, used with permission from Douglas Miles Clark. Closing music is Apollo from the 2001 album Into the Known by the band Sapphire. Thanks for hanging out with us and getting to know a little bit about our guest. We'll see you next time on Fascination Street.